Okay, today I'm gonna show you how to find the volume of a solid using cylindrical shells. So suppose that you wanted to find the volume of the region y equals to the square root of x, y equals to 0, and x equals to 4 about the y-axis. Okay, the first thing I'm going to do, I'm going to draw the region. So here is the x-axis, here is the y-axis, this is the square root of x, and then this is the line x equals to 4, and then the line y equals to 0 is just going to be the x-axis, so I'm not going to draw it. But this is the region that we want to revolve about the y-axis. So a copy of that will look something like this. Okay, we're going to use cylindrical shells. So the way this is you're going to measure, well, before that I'm going to go ahead and put, this point right here. This is the point 0, 0, and then this is the point 4, 2. So this is where x equals to 4 intersects with the square root of x. And I'm going to write, measure a little distance from 0 to x. And from this, I'm going to put like a little strip that is parallel to the y-axis, which is the axis of rotation. And I'm going to do a copy on the other side. And then I'm going to create a cylinder. So this is sort of like the inner wall, and then this is sort of like the outer wall. And the volume using cylindrical shells when you revolve a region about the y-axis is equals to the integral from a to b 2 pi times the radius of the shell times the height of the shell with respect to x. Okay, for this particular example, the limits of integration are 0 and 4, the x values. The shell radius is just how much we measure from the center of the shell to the vertical line x. So in this case it would be just x, or x minus the center, which is x minus the vertical of rotation, x minus 0, which is still x. And the height of the shell, so I'm going to write shell height. It's just the square root of x minus the line y equals to 0, so it's just going to be the square root of x. So the radius is x, and the height of the shell is the square root of x, and then you're just going to integrate that with respect to x. Okay, so then after that you just take the integral from 0 to 4. You can take the 2 pi out if you like. And then the x times the square root of x is x to the 3 halves. And that's how you have to do. And then integrate. So 2 pi, So the 2 pi is because this is sort of like the circumference of the shell times the height of the shell. Okay. X to the 5 halves times 2/5 is the integral of x to the 3 halves as x goes from 0 to 4. Then this is equals to 4 pi over 5, and then you just plug in the 4 there, raise it to the 5 halves, and after you do all this you get something like 128 pi over 5. That is the volume of that solid using cylindrical shells. Okay, now suppose that we want to find the volume of the solid between the 2 regions that are given by the following. So we have y equals to 3x minus x squared, y equals to 0, and we want to rotate this about x equals to -1. So it's a vertical line. It doesn't necessarily have to be the y-axis. Alright, this time when you take your graphing calculator and graph the parabola and the line y equals to 0, eventually you will get something that looks like that. And so I'm gonna find out what this point and what this point is, and as you can see, you find those by setting 3x minus x squared equals to 0. Factoring out x, you get 3 minus x equals to 0. So x equals to 0 and x equals to 3. So this is the point 0, 0, and this is the point 3, 0. Now we want to rotate this about the line x equals to -1. So a copy of this will look something like this. I'm not gonna have like sufficient what is it called, sufficient paper here to draw the entire region, but this gives the point across is supposed to go from -1 to -4 and so on and so forth. And so here is the distance that I'm going to measure from 0 to x, and then this is going to be like the copy of that, so that I can draw my cylindrical shell. It's going to go like this. This is the inner wall, and then the other wall is going to go something like this and like that. Okay, this time the radius of the shell, so shell radius, is how much we measure from 0 to x plus the axis of rotation, or minus the axis of rotation, so it'll be x minus a -1, so that becomes x plus 1. That is the radius of the shell. It's not just x, this is x plus 1. The height of the shell for this particular example is just the function 3x minus x squared, because it's the height of the cylinder, which you can think of that cylinder as a can, green beans can or something like that. Anyway, the volume then, the original region goes from 0 to 3, so the volume will go from, again, from A to B. This is, I recommend this formula rather than Anything else? So it's always from A to B if you revolve about a vertical line. The shell radius, and the shell height with respect to x. And in this case, A is equals to 0 and B is equals to 3. So the shell goes from 0 to 3. 2 pi. Because the radius of the shell is equals to x plus 1. And because the height of the shell is equals to 3x minus x squared, dx, that is the setup to find the value. Now you just have to, here in parentheses, I'm just going to put, what is x plus 1 times 3x minus x squared. If you FOIL that, you get 3x squared minus x cubed plus 3x minus x squared. And then that's equals to 2x squared plus 3x minus x cubed. So I put that in parentheses and I'll put the equals over here. So this is going to be the integral from 0 to 3. You can bring the 2 pi out and then integrate 2x squared plus 3x minus x cubed with respect to x, like this. After that, you just integrate. So integrating 2x squared, you get 2x to the third power divided by 3 plus 3x squared divided by 2 minus x to the fourth power divided by 4. And then you just plug in the 3 right there. So that gives you 45 pi over 2.